Hi everyone, my name is Amanda Nakhul, and for this year's Talaria Summer Institute research project, my mentor and I decided to study trends and body size of modern sharks through the last 66 million years. So what exactly are we addressing? The question that we're trying to answer is, can we observe certain trends and different intrinsic traits of sharks throughout the last geological era? As for an introduction, sharks are a diverse group of cartilaginous fish found in all modern oceans from the pole to the equatorial coral reefs. They represent keystone marine species, providing essential ecosystem services in their environments. Their roles range from apex predators, such as the great white shark, to filter-feeding giants, such as the whale shark. Unfortunately, this diversity is currently at risk of diminishing or even disappearing. Sharks, alongside their cousin group rays and skates, represent the most vulnerable group of marine vertebrates. The main drivers of their decline are, of course, human activities, primarily fishing. Sharks are directly targeted as commercial catch or are often the victims of bycatch or entanglement in industrial fishing nets, in which they cannot escape, and this declines their population a lot. Moreover, to body size. Body size can be indicative of many things. For example, the evolution of giantism is often associated with certain environmental changes, which allow for a higher abundance or better accessibility to prey, such as the evolution of large-bodied filter-feeding whales. And if a large body size evolved under certain conditions in the past, and those conditions have shifted in the present, body size now might not be beneficial. So it might be valuable to explore whether certain body sizes had tendency to evolve at similar times, so we can sense a trend. I know the data is hard to read, but we had a bunch of different data separated by taxa, order, maximum total length, origination time, and epoch. And I'm going to give you guys a second to look at it because it is a lot of data. And how do we acquire new data? So information on a maximum body size of extant sharks were collected from supplementary materials and it contained various information on intrinsic characteristics of extant sharks, but the times of origination were provided by my mentor as they were not publicly available yet. And the two datasets have been cross-checked to identify species for which both types of information were available. And subsequently, the resulting data set contained a list of combined species names with maximum body size and origination time assigned. And the origination time was also used to assign the geological epoch in which each species originated. So basically, one data set led to another in our case. And all data manipulation was carried out using pandas and numpy packages implemented in Python, version 3.88. As for our data analysis using the NumPy and SciPy Python packages, exploratory analysis of the data were carried out. And to identify any trends in body size through time, a linear regression analysis was carried out by fitting a linear regression model to the data using the linear regression function from the SciPy package. And to identify any differences in body sizes between the different geological epochs, an ANOVA analysis was carried out using the f_one-way function from the SciPy package. And these results were plotted using matplotlib and Seaborn Python packages. So for our results from 53 unique, oh, I'm so sorry.
No worries.
From 53 unique extant shark species, we were left with these 6 orders, and the order with the highest number of extant species was Carchariniformes, which it was not surprising that they're the most species-rich order in the study because they're the ones with the highest number of extant species. So they did contribute to a lot of the data that were collected. As for the scatter plot and the linear regression, as well as the box plot and ANOVA, the linear regression was used to explore the trends, as said before, if there was an increase or decrease over their evolutionary history. And we were left with an intercept of 228.4 and a slope of -4.831, indicating that there is a decreasing tendency. This tendency, however, was not significant, with the model having a p-value of 0.0727 and a weak r-squared value of 0.063. Similarly, an ANOVA was carried out to test whether the median body size differed between the different approaches. The p-value of 0.958 indicated that there was not really significant differences between the approaches. So we took that into account. And finally, for our conclusion, this study was aimed to identify any patterns and trends in the body size of extant sharks throughout their evolutionary history. And the resulting findings indicate that there is no increasing or decreasing body size tendency towards the present. There is also no significant outliers except for the Rhynchodon typus, which is also the only filtered feeding species in the study, indicating that a large body size might be advantageous in the long term of this mode of diet. However, the remaining predatory species all fall within the stable range of body sizes with no significant outliers, indicating that here is an optimal range for body size in sharks. And thank you.